Welcome to Study Loop.
Let's evaluate a given integral. Here, we should see if we can factor the denominator. And we can. This is a difference of 2 cubes. So we can write this as 1 over x minus 1. And then we'll have x squared plus x plus 1. And then we should look at this quadratic in the denominator to see if that factors. We can look for the discriminant, b squared minus 4ac. Here, b is the coefficient in front of the x. It's just a 1. So that's 1 squared minus 4 times a. The coefficient in front of the x squared is 1, and c is also 1. So we have a negative quantity. That means that this quadratic will not factor. And so now the partial fraction decomposition should look like a over x minus 1. That's what the author calls case 1, non-repeated linear factor. And then here we have case 3, because we have an irreducible quadratic factor. And now we'll just go ahead and find a, b, and c. So let's multiply both sides of this equation here by the denominator on the bottom left. We have 1 equals a, x squared plus x plus 1, and then bx plus c, and then x minus 1. And let's just go ahead and expand this right-hand side. Ax squared, ax, a, bx squared, cx, minus bx, minus c. And then let's combine like terms. So let's factor out x squared. We see that there's a plus b. Let's factor out x. That leaves us with a plus c minus b. And then our constant term left over, a minus c. So this will give us 3 equations and 3 variables. So a plus b, we see that there's no x squared term on the left. That means a plus b 0. Similarly, there's no x term on the left. There's just a 1 there. So that means that a plus c minus b is also 0. And then the constant term on the right must be 1 to match the one on the left. So now we have a 3x3 system that we could solve for a, b, and c. For example, the first equation, you could solve that for a. Then you could plug this a value into the other equation here, the second one. You could c minus 2b equals 0. So c equals 2b. And then from the last equation, you have a equals 1 plus c. But c is equal to 2b. But then 2b, because of this over here, equals negative 2a. So we can solve this for a. We get 3a equals 1. So a equals 1/3. Then that gives us b equals negative 1/3 from the circled equation over here on the left. And then c is 2 times b. So we have c equals negative 2/3. So those are our constants for a, b, and c. We'll just go ahead and plug those in up here in the upper right. And then we're ready to integrate. Let's go to the next page. So our integral can be written, plugging in our values for a, b, and c, of course. So that's the b and the c, and then we had the quadratic. Now we could split this into 2. actually 3 integrals here. So let's go ahead and distribute this integral sign. We could pull up the 1/3, 1 over x minus 1. And then for the next term, let's actually just leave that. Let's just pull out a minus 1/3 here. And I'll just have an x plus 2. And then for this denominator here, let's go ahead and complete the square. So that'll be x squared plus x. And then there's a 1 in front. Take half of that and then square it. And then make up for this by subtracting 1/4. So we get x plus a half squared plus 3/4. So that'll be our denominator here after we've completed the square. Let me write that as √3/2 squared. I'll write it that way so that in case we have to use sub, it'll be easier to see what the a is. So for the first integral, this is just 1/3. Natural log, absolute value x minus 1. Now if this minus 1 is bothering you here in the bottom, feel free to do a u sub. And then for the other integral here, you may go ahead and try trig sub right now. What might also work here is to rewrite the numerator. So let me write this as x plus a half. So all I'm doing here is writing 2 as a half plus 3 half. And the reason I'm pulling a half is because I see x plus a half in the denominator. So let me just leave the 1/2 here. I'll deal with the 3 halves in a second. So that deals with the 1/2 here. And now for the 3 halves, I'll just come down and write that on the side. So I still have this minus 1/3 that was outside the integral. And then just 3 halves up here. Again, this wasn't the only way to solve this problem. You could use trig sub right away. We'll still use trig sub in a moment. Just simplifying the problem. And dx. Now we've already evaluated the first integral here. We have our natural log. Now we have 2 more, one in the red, one in the green. The reason for pulling out the x plus 1/2 was so that we can use a u substitution for the red one. So for this integral in red, we should take u to just be, in this case, just take u to be the whole denominator. Three over 4. And then du is just over 2. Du over 2 is just x plus a half dx. And that's exactly what's in the numerator. So we can go ahead and write this integral in red as negative 1/3. And then we have a du over 2. So that should be there. And don't forget the 1/2. And then all we have left over is 1 over u. So this is just negative 1 over 6. ln, absolute value u. Negative 1 over 6. Natural log. And then just replace u with this term over here. X plus a half squared. Plus 3/4. And this can also be written as just, let me write it down here. Just a nice looking expression here. X squared plus x plus 1. Just simplifying that square. So we have 2 of the 3 integrals. We have 1 more in green. For this one, the u sub just won't work out as nicely here because it still will require a trig sub. So in this case, let's just go straight to the trig sub and let's go to the next page to do that. So we had, for the green integral, the last one, And in this case, let's go ahead and cancel those 3's actually. Sorry about that. So we had 1/2, and then we have dx, x plus 1/2 squared, plus √3 over 2 squared. There, we go for a trig sub. X plus 1/2 equals √3 over 2 tan theta. Then dx is √3 over 2 secant squared. So let's go back and write our integral out. 1/2. So dx √3 over 2 secant squared theta. And then in the denominator, we have x plus 1/2. So that's this term over here, and we'll square it. So we have 3 over 4 tan squared plus 3 over 4. So this denominator, pull out a 3 over 4. You get tan squared plus 1. And we know tan squared plus 1 is secant squared, so we can cancel those terms. So then we could go ahead and simplify these fractions, and we just have, after canceling, we have another 2 here, and then that 4 will go in the numerator, so the 4's will cancel, negative √3, and then now we have a 3 on the bottom as well. The secant's canceled, so we're just left with d theta. Integral of that, just the theta. And then at this point, use your trig sub to solve for theta. So theta equals arctan x plus 1/2 over √3 over 2. And let's go ahead and simplify these fractions. It's getting a bit messy here. So I can write this as tan inverse 2x plus 1 over √3. I just got a common denominator of 2 on numerator and denominator, and then cancel the 2's. So this is the final integral. And we're back in terms of x now. So the last step will be to just go ahead, this won't be our final answer, that was the third integral. Now the last step is to just go ahead and add those 3 integrals together. So let's go to the next page to write that out. We had natural log x minus 1. That was divided by 3. Then we had minus 1/6 natural log x squared plus 1, x plus 1. And then finally, for the last integral, using the trig sub, √3 over 3 tan inverse 2x plus 1 over √3. And don't forget our constant c of integration. And that's our final